Okay, ready?
Yes.
Yeah.
Pirate walks into a bar. And the bartender notices, he's like, hey, what's up? You got a steering wheel sticking out of your fly of your jeans there. Like, what's up with that? He goes, Arr, I know, it's driving me nuts.
Oh, yeah. It's driving me nuts, bro.
No, I get it.
You don't get it, bro? I didn't say run, but real stuff.
It's like driving him, not like it's
Yeah.
bothering him, but at the same time, it's also,
Driving.
Steering is
that's what makes it PG.
It's posted on YouTube.
It's
All
rated.
right.
It's rated R.
Finish these up here, and then we got good stuff for today. We're going pre-calc today. It's exciting. Straight Big Ben style pre-calc. Right out of their book.
Yay. Right on.
I'm going to do the hard part for you, and then you do the... Okay. This one, though. Consider x squared plus bx plus 9 equals 0. Enter a value for b so that the equation has no real solutions. What was your strategy here? What did you try? What did you do? How'd you figure it out? Or maybe you just didn't? I don't know. What did you do, Natalie?
Wait, which one?
Or which one? 13.
What did you do, Karen? Karen, you got the highest score on the SBAC test we took on the computer. Nice work.
Sweet.
Just thought of that.
Honestly, I got the wrong.
Somebody got 0.
Was
That was impressive.
I was probably you. I didn't even finish it.
Oh, of the people who finished,
Okay.
someone got 0 correct. That's like, nice work.
Well,
Okay. It wouldn't give me your scores. Like, I wanted to like just give you guys your scores, but I would have had to sit there and calculate them all by hand. And so I was like, eh. They weren't great, but we'll work on it. We're getting better.
Sweet.
I didn't know, I know we're off topic here, but it had exponentials in it, and the title of the test said quadratics, and so that was a complaint of mine. Like, it's going straight to like the state to like get fixed, because I was like, you called the test quadratics, and then you have freaking exponential questions in there. No wonder no one got it right.
if you do it one more time, I'm gonna beat you up.
So anyway, yeah. Other than that, you guys did pretty good actually. Most of you were like at or near standard, is it?
Oh, what?
Huh? It won't let like.
Why don't you just have it like tell us if everyone yellow?
Most of you were yellow. Karen was the only green.
What do you mean most of us? Like, there's that one. Like,
There were some reds.
I was honestly.
yeah. If I'm not the 0, I'm impressed. Like, no, I'm dead.
I'm dead, too.
Like, if I'm not the 0, I'm graduating. I know. You sound like you're spazzing over there, bro. Yeah. Yeah, look, bro. Hey, look.
Alright. See if I can figure out any more.
Yeah.
Okay, bye.
I got like a 10.
Trying to get it pushed to the 15. Here we go. What'd you do? The SBAC. How many of you are in state going to state FFA? I said a high percentage.
You say high.
Pretty high percentage.
3 out of like 27.
3 out of 30. Alright, I'm gonna tell them that part. I thought there were more. That just means more review for everyone else. It's not really review, it's new stuff. How do you figure out B here? To where it has no solution. No clue, huh?
Which has a, like...
No solution. Didn't we talk about this? Wasn't it like it had to be like a measurement or something like that?
B squared minus bar.
Anyone have an answer?
Yeah, the ending has to be
7.
17.
17.
0?
Yes, 17.
No. Wait.
See?
How do you guys know?
Come
I
on.
think you're right. and
Come
they're
on,
wrong,
baby.
actually. Because look, if you plug in the stuff you know, like this would be the quadrant. This is called the. This is part of the quadratic formula.
What is it called?
It's called the discriminant. Not a big deal.
Oh, yeah.
But, if you plug in the numbers you know it's going to be minus 4 times 1 times 9. Well, then this b right here is going to be b squared. 4 times 9 is 30. So you're going to subtract 36 from whatever b squared is, right? So actually 7 is not correct because 7 squared would be 49. 49 minus 36, you would have the square root of 13. You could do the square root of 13. You're going to get 2 answers. They're going to be decimals, but 17 also doesn't work because 17 squared is big. 0 works. 6 doesn't work because 36 minus 36 is 0, and you're going to get an answer.
So anything below 6.
Anything below...
Between 6
No,
and 1.
Below 6.
I'm confused.
In between
I'm
0
kind of
and 6.
confused. Like,
It has to be a negative.
Here's a number. Here, like let's say b was 2.
what does it have to equal?
The square root of 2 squared minus 36 would be 4 minus 36. That would be this negative 32. You can't do the square root of negative 32.
So anything
There would be no solution.
Oh snap.
And you're supposed to get 0.
So anything below.
Anything that causes it to be a negative square root.
Anything
Yeah.
below 0 above 1.
We all agree b has to be smaller than 6.
Yes.
But there's another stipulation.
0.
It can't, it can be negative.
B is less than 6 but greater than 0.
Greater than 0?
Greater than negative.
Yeah.
Is that true?
It's greater than or equal to 0. Well, I know what that
Oh, actually
means.
0 does work. I'm not a smart man. I'm sorry. If you put in 0 for b, did I say 0 wouldn't work?
No, you said
Yeah.
it would.
No, you said
Oh, if you put in 0, you'd get negative 36. That's no real, there's no answer, no solution. No real solution. You'd have to use imaginaries.
I only put 1 because it said enter a line. Just 1.
Yeah, I'll look
Yeah, if you only put 1, that's fine.
But isn't that what we're looking for? So
So you can just put 0.
Yeah, so 0 would work.
Yeah.
Or, it's confusing. 0 would work or would it wouldn't work
It
in
would
the
work- it would
quadratic
work for the
formula.
answer.
It works for the answer,
Yeah.
yeah. Ooh, it's
Gotcha.
very confusing, I know.
So there's many different ones that work.
There's well,
So
there's,
the thing is, you have to get no solutions.
you have to get a negative under the square root.
Okay.
Would negative 10 work for b?
Right.
No, because when you square it, it's going to become positive 100. So that's why I was saying it also has to be greater than negative 6. Anything between negative 6 and 6 would give you a negative under the square root, and then you would have no solution. You only had to put one answer. You didn't have to do this. I'm just picking it up a notch, you know? As usual. Does that make sense? Whatever, done with all the confusing.
No, it's alright.
Put in 0, you get negative 36. Hey, you get an imaginary solution. Put in negative 5. You get 25 minus 36, you'd have a negative over there. You're going to get an imaginary solution. You can't put in, notice I didn't put equals, because if you actually put in negative 6, you would get 0 under the square root, and you can do the square root of 0. So therefore, you would get an answer for the x-intercepts.
What's the square root of 0?
0. 0 times 0 gives you 0. Okay, I think this one's similar. I like these ones. Gives you an equation where k is a real number. Enter a value for k so the equation has no real solutions. Oh, this one's easy. 0 is incorrect. 7 works. 7 is correct for the problem. I don't want to do works or doesn't work because then that gets confusing. But so think about this. What will happen if we're going to get no real solutions for this? How do you solve this? How do you find the solution for that equation? You what? Plus k equals 0. Let's say that's a number. What would be the first step to solving that? Subtract k, right?
Yeah. That way.
So then you would have x plus 3 squared equals negative k, and then what would you do?
Divide by 2? No, yeah.
Square root it.
You can't do it.
You can't do the square root of a negative. So in this case, what could k be to make it be no solution?
Any negative
Any positive
Any
number.
positive number.
Yeah, because it's got the negatives.
Because you're going to subtract. If k was negative, then you would add it, and it would work. You would do the square root. But any positive number would give you no solution. So anything, it's greater than 0. that one make sense? Kind of? Ooh, and then this one I saw a lot. I kind of looked at this problem when I looked through your papers.
I just yelled help on
Yeah.
I just didn't.
That's why I put it last. I did that on purpose because I thought it was one of the harder ones. Gives you a graph, y equals p of x. There it is. Select one or more intervals. You know what intervals are? Who's done intervals?
Like the in-betweens.
Yes.
It's like sections of the graph. Remember when we did piecewise?
The piecewise functions.
The piecewise functions?
Yeah.
You would have like y equals, and then you'd have some crap right here, and then you'd have like -3 to x to 4. That's an interval. That means all of this part of the graph in between those x's. That's an interval.
Is that what we like on number 13? The answer, like -6.
Yeah, that's an interval also. Everything between -6 and 6. Yeah, those are intervals. Usually they're written differently than that, but you get the idea. It's a section. It's a whole chunk of it. So we're selecting one or more intervals with consecutive integer endpoints. Ooh, some big math words there. What's consecutive integers?
One after.
One after another. Integers, no decimals. That contain the solutions to the equation 13 equals p of x. What does that mean? 13 equals p of x.
Y equals 13.
Y equals, not y-intercept, just y equals 13. So all this is asking is, when will this graph approximately hit y equals 13?
I'm trying to find the x values.
We can't do it exactly, but look at this goes 2, 4, 6, 8. This would be 10, right? And then we'd hit 12. 13's like right up here where the words are, right? So if this graph continued, where does that function hit up at 13? When y equals 13, what would x be approximately? 4 or 5? You think it's going to be way out here?
4. Oh, it's 4.
Positive 4, negative 4.
Yeah.
Okay. But you don't know for sure that it's 4, so that's why they're saying pick consecutive integer endpoints. I think it's going to be somewhere between 3 and 4. What do you think? Do you agree?
Yeah.
Or do you think between 4 and 5?
I think 4
That's
and
what the
5.
consecutive integer means. It's either going to be between 3 and 4 or between 4 and 5. That's the answer. What do you...
4 and 5.
4 and 5?
Yeah, bro.
No.
Cause look, it's opening.
No, I feel like it's...
But
I think
as
it's right
parabolas,
right on the edge of 4.
as you
Yeah.
go out from the vertex on a parabola, they get steeper and steeper. It's not going to get like shallower and like go like that. It's going to continue to get steeper and steeper as you go to the right. And as you go to the left, it's going to get steeper and steeper.
So from -3 and -4.
So I really think it's between 3 and 4. Somewhere between those two is where that graph would hit 13.
So that's how you fill in the line.
You'll be on a computer, and it'll ask you to like click and draw in the little line. We'll do another one of these practice tests. Did they have those like that on the one you did?
No.
We had to like,
No, bro. We had a bunch of whatever you said.
exponentials. Yeah, well, the one was like, which one represents exponential growth and decay? One person in the class got it right. I was like, oh, cool. I think
They got
that's
100%.
I just looked at like the stats. Pre-calc time. These are just like example problems. It's not new stuff. It's just applied in a different way.
Are you using that other way or not?
As you guys like to call it, story problems.
You want to teach us the fourth way?
Not yet.
It's the fourth way.
Wow, baby.
Next week.
You said that last week.
Well,
Well, then it's
not
best
moving
to-
as fast as I want.
We move faster to do the fourth way.
So with me.
You can't quite yet. I promise I will tell you.
You're probably gonna tell us when we figure it out.
Is it gonna be like the
Suppose that you have 500 feet of fencing available for a rectangular pasture alongside a river. Yes. I can actually put the words up here. You have 500 feet of fencing. Know what that means?
Yeah.
Like you got 500 feet of stuff to build a fence. And it's going to be alongside a river, with the river serving as one side of the rectangle. So a picture of that would be like, here's your river, that's the water. And you're just going to build, well, let's assume it's a little straighter. You got 500 feet of fence, and you're going to build a fence like that to keep your cows in here.
You're leaving the riverside open?
Yeah, the side on the river's open.
So they can,
That's what this says. The river serving as one side of the rectangle. So only 3 sides require the
So is
fence.
the river straight or is it going to be like this gravel?
We're going to assume it's nice and straight
Okay.
for just this small section. Find the dimensions yielding the greatest area.
Perimeter's
Yes.
500.
So you have 500 feet of fence. We want to know how big should we build at each side so that we get the biggest possible area for the cows or whatever you're keeping. I will tell you, guess and check is not a great way to do this. So here's the pre-calc part I'm going to do for you, and then you're going to do the algebra 2 part, okay? But in the process, you're going to be like, oh, that's not bad. Pre-calc's pretty easy.
Well, you did the hard part.
We know we got 500 feet of fence. How long is this side going to be? X, good. I was expecting a number, but that's nice. Yeah, just X. I don't know. I'm going to make it some length. If this side's X, how long is this side?
X, same thing.
Also X. If this side's X and this side's X, how long is this side?
Y,
Ow.
Q.
Okay, Y, sure, but
Or
we can be
L or
we can be
something.
more specific than just throwing another variable in.
R.
That's just that's another variable.
Well, it's river.
Okay. No. Look it. We know we only have 500 feet of fence.
500 divided by
I
x.
drew a square.
Or
Closer.
no,
Divided by
it's
x.
500 divided by 2x divided by 2.
No.
Right?
X squared minus.
500 minus 2. 500 minus.
Stop guessing. What?
So, I'm thinking like, if you divide 500 by 2, you can put 250 feet on the longer side, and then you divide that by 2 between the x's.
Sure, you could. You could do it a whole. There's infinitely many ways to do this.
I was thinking like,
You could do 400, 50, and 50. We're just trying to get the biggest area. All I want to know is how long this side was. Ellie, you were getting there. Let's put actual numbers. If this side was 50 and this side was 50, how long would this be?
500 divided by
That's what I said.
So you guys are saying it. 500 minus 50 minus 50. So now just use x's.
So x times
500 minus.
minus 2x.
X
2x.
squared. Stop. Don't say that. Just say that.
This side is 500 minus these 2 sides. Okay. Now, what is the area of this thing we just drew?
500x minus 2x squared.
You're advanced.
Times
X squared.
Don't we just multiply the sides together?
Yeah.
It's a rectangle based on 10.
X squared.
So x times 500 minus 2x.
Isn't it?
Wow,
X-
you're smart.
Oh, wait,
And she already did distributive property. That's why I was like, that's good. 500x minus 2x squared. There's the hard part.
Wait, what?
The hard part was getting the formula for the area.
I understand this more than I do the others.
Now,
Chuckle, chuckle.
if you were lost through that, not a huge deal. You don't actually have to do that at this level.
So you know you just like complete the square.
But now, it's your turn. Now, you need to figure out the maximum area, right?
So it would be y equals 500
Hold on.
squared plus 0.
Don't yell it out. I want everyone to have a chance to think. If we're trying to find the maximum area, how can we use this to accomplish that?
Solve it. Solve for y.
Shh, don't yell stuff
You need to
out.
calm down, bro. We're all trying to try.
You don't necessarily have to listen to those suggestions. In fact, I wouldn't recommend it. You want the maximum area. The biggest possible value for A. Now I'll take a suggestion. Solve it. What do you mean solve it? Get x by itself? How are you going to get rid of that A?
You would have to divide.
A is not 500. A is
the area.
area. 500 was the perimeter. Or not the perimeter, the fence. The perimeter is, we don't even know.
Well,
We don't even care, actually.
Can I just? I'm going for it.
What are you going for? What are you gonna do?
Wait. You see that line where the guy at the crosswalk stopped the button? Wait.
Ooh, how convenient.
2,000? Sorry.
I was gonna do a different example to get you to think of what to do.
Do that.
Let's say you had, this is completely unrelated. Well, not completely. I'm gonna give you an equation here.
It's 2,000.
Let's go. Negative x plus 3 squared. Can you tell me what the maximum value for y, if you graph that, would be?
Negative 4.
Negative 4. How did you know?
Because it's the
Oh,
Y.
Because if you graphed it, it would be negative 3, negative 4, and it would be upside down. So you know the maximum value for y is the vertex, right?
Yeah.
Negative 2x.
Hold on. That's the whole idea here. If we're trying to find the maximum value for this over here by itself, it's basically just the vertex. This is a quadratic, right?
Oh,
If
yeah.
we want the maximum value for a, if we were going to graph this, a would be on this axis, this would be the x-axis. It's going to be an upside down parabola. I don't know where it's going to go yet. Now if you take it.
Oh, I get it.
Oh,
Come
so
on,
what
baby.
A few people are on board.
Like I get it, but
Dang it!
Got this, baby.
Now I gotta pull 2 out.
What are you doing? Why are you pulling 2?
No. 500, right?
What are you pulling 500?
Oh.
What are you doing?
Yeah.
Tell me what you're doing. I don't know what you're doing.
Well, first you should put that.
Don't you need to complete this?
Complete the square. Why are you completing the square?
Because you want to get into that other.
You want to get it into vertex form, right?
Yes.
Oh, so we can
So you
find the
gotta-
highest
Yeah,
possible.
so you're gonna pull out 500.
Okay, is this written in standard form?
No. It's gonna be negative 2x squared plus 500.
Now could you complete the square so then you could tell me where the y coordinate of the vertex is, and that would be your biggest possible area?
500.
No.
What is it?
I'm gonna complete the square.
Pull up the negative 2. Yeah, you
So at this point, yeah, you have an equation here that if you graphed it, it would be an upside down parabola. You're completing the square to figure out where the vertex is.
so you pull out negative
So we
2.
have to like figure out how low the river part is.
Not yet.
No? Okay.
All you're doing here, completing the square.
So,
There's no value back here, so it's just boom, boom, okay. Pull out the negative 2. So you got x squared minus 250x. Half it, square it, add it, subtract it. I'll be your calculator for you.
Half it is negative 125.
Yeah, half is
I
negative
can't score that.
125 squared is 15,625.
Holy cow.
Dude.
It's gonna be a big thing.
Plus
That guy's rich.
15,625 minus 15. He still only has 500 feet of fence, folks. It's just area.
yes.
Wow, those cows are going to have a lot of grass to eat.
And you bring out the negative.
negative 2.
Yep, and multiply by negative 2.
Where are we getting the weird
big numbers?
Negative.
That's when you do
Divide by 2 and square it and square it.
square.
You take half of that one and then square it to add, and then you add and subtract it in the parentheses.
Yeah.
You might not have been here.
No.
YouTube, completing the square.
Oh, is that the name of the game?
It's the date, and then it says algebra 2 and completing the square.
And it has Hopkins face on it.
And it has me.
Minus 125.
No, it doesn't have me, it just has the word. So there we got that.
So negative 250.
Okay, negative 2 times x minus 125 squared plus 31,250. We've completed the square. Now back to the original question. What is the maximum area of the fence? Or of the, not of the fence.
31,250.
The max area would be
31,250.
31,250. 250. Is this feet? Yeah, feet.
Yeah, let's get some feet.
Feet squared.
Now I have to figure out the.
Now my next question would be, what would the dimensions of the fence need to be in order to get that area?
Well, then you just do the formula. Instead of A, you put 31,000 whatever, and then.
You want the dimensions of like the side?
I want to know how long should I make this side, how long should I
So
make
just
You could
do
make
the.
it as long as I
Yeah.
I told you that
Yep.
before.
It was a good guess.
No.
It wasn't a guess, so it didn't matter. Without all that confusing stuff.
So one side is
Look at-
125 and the other.
Isn't the vertex, look, if you graph this,
Uh-huh.
here's the area, here's the x, which is the side at length, right? Wouldn't the vertex be at 125 and then up to 31,200 and whatever? Right?
Yeah?
So wouldn't the x value to get the biggest area be 125? So that tells you, hey, make this side 125 feet,
Other side
make this side 125 feet,
And R
and
is
make
the-
this side, if you plug in 125 for x, that side will be 250. So your fence would be 125 by 250.
Wow, babe. Now I know how to make.
The
how
biggest
many-
fence possible.
Yeah, with 500 feet.
I'm going to give you one now that you can't guess.
Oh.
Same exact kind of problem. We're going to build another fence. 3 today.
Oh. I'm excited.
I didn't like that.
Suppose you have 1,800 meters of fencing available with which to build 3 adjacent rectangular corrals as shown in the figure. You're going to build 3 pens. Find the dimensions so that the total enclosed area is as large as possible. Same kind of problem, just now 1,800 meters. We can do feet if you don't like meters.
I don't like that stand.
Let's just do meters. We're doing meters. Here's our fence this time. This time we need fencing on all sides.
Even in the middle, don't we?
Even in the middle, yes.
But it's a 1, 1, 2 thing, right?
Dang it.
Like 1, 2.
One is larger than the other.
See, this? One on the other piece of paper.
Oh,
One's larger than the
the
other.
size? Technique, actually, I'll tell you on this one,
You
it
don't-
does not matter
Same
which,
distance.
what, the total area is still the same no matter where you move the 2 inside fences.
So just do-
It doesn't say like make this one the biggest and then the top one, it doesn't matter. We just want the total area to be as big as possible.
So then you don't need to know that it's 3 divided
You
sections.
do need to know that it's 3 divided sections because you only have 1,800 meters of fence and you need that fencing in the middle, so you can't just
I
make
put
the
some
outside.
plywood, bro. Just kidding.
You're out of money. We gotta corral those cows up because now they've been swimming in the river, so we need to discipline them. Okay, pre-calc part is writing the equation.
So it's gonna be
What do you think we're gonna make this side be?
X.
X.
And
And all the lines in the middle are X.
Those are all x.
It's gonna
Yeah.
be.
So then how long is this side? That's the hard part.
Oh.
I got
1800 minus x to
It's
the third.
close.
No,
2,
3.
3, 4.
Minus 4.
It's 1,800 minus 4x, but we need 2 of them.
times 2.
Times or
Put it in
Square.
parentheses.
squared.
No, no.
Divided by
2.
Divided by 2.
Ah.
Each one will be divided by, it says we'll have x, 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 x. So if that's 100, 100, 100, 100, 100, that'd be 400. So we take 1,800 minus that 400, will give us 1,400 to split between these 2 sides.
Ah.
So if I divide that by 2, that tells me that one side.
There's 2 sides, not one.
Okay, got it.
We could simplify that. 900 minus 2x. So then the area is what? What's the area
X
of the
Is
times
X times 900.
900 minus 2x.
100